In this video, we're going to look at some new functions to add to our library of functions, and I'm actually going to be doing these on the graphing calculator. So if you have one, you need to get yours out so that you can follow along. So we're going to start with f of x equals cube root of x. I'm going to show you how to enter it in the graphing calculator. Hopefully you'll be able to see this in the video. So we want to turn it on. We are going to set a window before we put our graph in. So if you will go up here and click on window, let me see if I can maybe lighten this a little bit. I think we'll just leave it. So the x min we're going to set at -6, the x max at 6, skip down, x scale, we still want to count by 1. Y min is -2, Y max is 2. Now I want you to go into Y equals, and we're going to put in cube root of x. The cube root function is found under the math button right there below alpha. And if you can see, you will notice that number 4 is cube root. So I'm going to pick number 4, and then I'm going to type in cube root of x. Enter. We want to graph that, so we go up here and we push on graph, and you will be able to see the graph, I think, fairly clearly. It's a little exaggerated, so it looks basically like this. Now, I didn't get my shape quite right, but you get the idea, okay? The properties of that graph are listed here on your notes. I'm not really going to go through all of these. I just want to show you these graphs. This is something that you need to memorize, these graphs, and know that they're shapes. These are the parent functions for graphs that we're going to use later. So we're just going to kind of go through these quickly. So let's look at, again, I'm not going to go over the properties of cube root of x. You can certainly read those on your own. Let's go to the next one, which is f of x equals absolute value of x. So again, on your graphing calculator, let's go to y equals. Let's go ahead and clear that so it's not in the way. And to find the absolute value, we're going to use the catalog, which is down here on the 0 button, right down here at the bottom of the screen. Notice it's up above, so we say second catalog. The very first one is absolute value. You see that? So I'm going to hit enter. Now it wants me to put in what I'm taking the absolute value of. I'm taking the absolute value of x. I go ahead and hit enter, and I want to set the window again a little differently here. So this time let's just go from x min -3, x max 3. Oops. Let's go back to window. I don't know what I did. -3, x max is 3, and we're going to do skip down. X scale is good. Y min we're going to put at just -1, and then Y max, we'll go ahead and run that up to 3. That'll give you a good picture of what it looks like. And now hit graph. And you can see what that absolute value function looks like. So if I sketch that here, it looks something like this. We're not actually looking at the points on the graph. However, if you wanted to look at those points, you could get into your graphing calculator and see those under table, which is up here, second table on the graph button, and you can see your x1 and your y1s. You can see them right there. We're not actually going to do that here. Now, if you want to look at the properties of it, you can see it's the domain of all real numbers, is the set of all real numbers. The x-intercept and the y-intercept, you can see that. It's symmetric with respect to the y-axis, so that makes it even. That's a review, etc., etc. Okay. Let's look at the next one, which is a very odd little graph. And this is f of x equals, this means integer x. So bringing back the graphing calculator, let's go into y equals. Let's hit clear. Let's go into window before we put it in, and let's set our window again at -3, 3, and then we're going to set our y at also -3, 3. Now we go into y equals. I'm going to go into catalog again, and I'm going to scroll down till I get to the i's. Now the other thing is you could have just typed in an I, but I'm just going to go ahead and scroll down by hitting my down arrow, which I'm now regretting because it would have been easier just to type in an I. I'm getting close to the h's and the i's, and I want to go down to integer. You will see that it is right there. So I went too far. There it is. I have my cursor on that. I'm going to hit enter. And now in the integer of what? We're going to do integer x. What that means is we want the point, whatever x is, we want the y that is the same or not greater than that integer. It's easier to show you than to try to explain it. So let's go to graph and look at what we get. We get a series of steps. Now let me graph this even a little bit more accurately, and I'm actually going to do an f of x table here so you can see this. f of x. So if x is -1, the integer that is closest to -1 without going over it is -1. If x is -1/2, the integer that is closest to that is -1. If x is -1/4, the integer that is closest to that is -1 without going over it. If x is 0, the integer that is closest is 0. If x is 1/4, we have 0. If x is 1/2, we have 0. And if x is 1, we have 1. So what we end up with, if I go over here, I end up with a graph that looks like this. It goes up to but not over. And then here we start, it goes up to but not over. Those are supposed to be open. My pen is kind of thick, so it's hard to see that. Here it goes up to but not over. Here we go up to but not over. I'm going to make it bigger so you can tell. Here it goes up to but not over the whole number. Here it goes up to but not over. So it's not equal to the one above it. It's the one closest to it without going over. Your graphing calculator only shows it as lines. So in general, it's a stair-step type of function. And the properties are listed on the next page. So if we look at this updated library of functions, the ones that you need to know are the constant function, what we call the identity, where y equals x, the square, f of x equals x squared, that's the parabola, the cube, f of x equals x cubed, the square root, f of x equals square root of x, so it has to be positive, it doesn't go into the negative side here. The cube root, f of x equals cube root of x. That's the first one we did in this video. Then we have the reciprocal function, which is f of x equals 1 over x. Let me scoot this down so you can see it. Easy one to remember because it is a fraction that has a numerator and a denominator, and my graph has two pieces also. The absolute value function, which is another one that we did today in this video. And the other one is what we call the greatest integer function, or the step function, and it looks like this. So let's look at, finally, the last function that we are going to analyze is what is called a piecewise function, or a piecewise defined function. Now these are kind of odd. Because they're made up of bits and pieces of function, and it's quite difficult to show this on the graphing calculator, so we're not going to do it. We're going to do it by hand. So if we look at example 3, it says here we have this function f of x, but it's defined in different ways depending on what x is. So for example, if x is between -1 and 1, including -1 but not including 1, then the function is -x plus 1. If x is actually 1, the function is equal to 2. If x is greater than 1, the function is equal to x squared. Now I'm going to use 3 different colors for this to sort of help you. So let's do this. If x is between -1 and 1, we'll do that in blue. or in purplish blue, okay? And I know that f of x equals negative x plus 1 is what kind of shape? That is a line. It's linear, okay? If x is equal to 1, then y is 2. That is just a point. If x is greater than 1, y is equal to x squared. That is a parabola. So we want to find f of 0, f of 1, and f of 2. This is actually easier than it sounds. So, and I didn't use the colors. This is supposed to be in pink. This is supposed to be in green. I'll try to do that on the graph, okay? So let's find f of 0. First off, where does the 0 fall in the definition? Isn't 0 between negative 1 and 1, right? So I will use purple. So f of 0, since it fits this, we're going to use this definition. It's negative x, which would be negative 0, plus 1, or just 1, which means that I have the point on the line part of my function. I have the point 0, 1. 0, 1. Now it's a line going through that point. I don't know yet which direction it is. So what I want to know is, what if x is negative 1? It didn't ask me to find that here, but I'm going to anyway, because I want to see if my line goes through that, or if it goes this way, how it goes. So I'm going to go f of negative 1 would be negative x, or negative 1, plus 1, which is 1 plus 1, or 2. So I know I have the point negative 1, 2. So I have this point. So I know my line goes like this. Now before we draw it, we have to be careful, because if you notice in your definition, x is allowed to be greater than 1, it's allowed to be 1, or it is allowed to be between negative 1 and 1, including negative 1. But is x allowed to be less than 1? No. X cannot be less than negative 1. So I know my line starts here, but it can't go negative 2, negative 3. It can't be there. So that's an end point. And then what happens to my line when it gets down to 1? Well, x isn't allowed to be 1 either. It's got to be less than. So I know that my graph goes like this, with that being an endpoint. It can't be 1, and it certainly can't be below that. So it's just this part of that line. So you really are having to do some analysis here. By the way, this is a stray mark. I didn't mean to do that. Okay? That's just the mark where x is negative 1. All right, in pink, let's look at this. If, well, we need to go ahead and find f of 1. So if x is 1, f of 1, we already know, is 2. There's nothing to do. So that gives us the point 1, 2. And that is if x is 1. So there is a point 1, 2. That point is part of my piecewise function. Just that point all by itself. Now we want to know in green, what if x is greater than 1? Well, I know it's going to be a parabola, and I know that the graph of x squared, I'm not going to draw it yet, looks like this if I were to draw it, all right? But in my parabola, I only want the part where x is greater than 1. So by parabola, I can't have my parabola being x being 0 or x being 1. Now it can be anything greater than 1. So if x was 1 and it really was the parabola, it would be 1 squared, it would be 1, 1. But I can't have that. There's a hole there. So it's like the parabola goes up to here and then it continues. I can't have it on this side. So the part of my piecewise function, the piecewise function itself, now I'm going to take my white out, I'm going to erase the part. It actually doesn't have this in it. There's a hole right there. It doesn't have this part. Let me see if I can do this. It doesn't have this part of the parabola. That is all whited out. Okay, we don't have that. And I don't have this little bit here. The parabola actually starts at that hole right there. So all I really have is this purple part down to here. I've got a lot of white out on there. I have the pink dot, that's this middle part, and then I have this green part of the parabola that starts at x is 1, but it doesn't include it, but it does continue as long as it's greater. So it's like a collection of pieces. Continuing on, it says determine the domain of f. Well, the domain, we can see, since x can't be less than -1, but it can be anything greater than -1. The domain is the set of all x such that x is greater than or equal to -1. There's a definition for it. As long as it's greater than -1, there's a definition for it. Graph the function. Well, we did graph that function. We graphed it right here. And then use the graph to find the range. Well, the range are the y values. So we can see going up, y can go all the way up to infinity. Is there anywhere where y is allowed to be down in here in the negative range? No. And is y actually allowed to be 0? No, there's a hole there. So the range is the set of all y such that y is greater than 0. So that is a piecewise function.